Hi everyone. So in the part A we completed, the part one we completed fine tuning of uh, LLMs using UnSloth, and then also the continued pre-training and also the chat template applications where we did classification and conversational start and also extended context with uh, and also multi-data fine tuning. So let's go with the third. I'm going to start with the second part in which I'll be doing the reward modeling using ORPO and DPO with the Phi-3 Mini. And then maybe we'll also continue with the continued fine tuning from checkpoint using Tiny Llama. So in this reward modeling, what we're doing is we're aligning the model preferences using state of the art techniques. So DPO is nothing but direct preference optimization, which uses preference pairs, as you can see. And also we're going to do the second method, which is ORPO, which is nothing but the odds radio preference optimization, which we're doing using combining LM loss with preference optimization. So here we used we have different models that we could have used, and we're using Phi-3 Mini on the Ultrafeedback dataset. So let me open the collab. So all of these links are present in my GitHub if you want if you want to check. So we have two sections for the DPO and ORPO, as you can see. So this is the first installation process. Like every single collab, like we'll have to start with installation, and also GPU is required for this. So I use the L4 uh, GPU for this. Okay, so this is the step where I'm installing everything, and then this is the DPO part. So here I'm doing the we're doing the UnSloth DPO patch. So the first thing we're doing is applying the UnSloth DPO patch trainer, and then taking all of the required libraries. We're just importing everything, and then we're just printing out saying all of the imports are completed. So here you can see that it'll patch your computer to enable 2x faster fine tuning, and also it'll patch everything to make training faster. So that is what we're doing over here. And then here we're just loading the model. So as I mentioned, we'll be using the Phi-3 Mini 4K instruct BNB 4-bit. So this is the this is a small model and it's capable of this task. That is why we've taken that. And then here we're defining the sequence length for the appropriate model. And then basically everything else what we need for the model to be run. And then this is the dataset sample percent, which is nothing but 5% of the dataset, then learning rate, number of epochs, and also the DPO beta that we need to define before. So we're doing all of that, printing that, and then this is where we're loading the model. So as you can see, this is the loading of the model, and then whatever we defined before we're giving over here. Yeah, so we're loading the model, we're just printing out the time, and then after that, all of the so we're just loading all of the models and the tokenizer. So here you can see that the model was loaded in 7.73 seconds, and then everything is done, tokenizer are also set, and then this is where we're doing the data we're defining the data preparation functions. So basically all of this we're stripping off the empty characters over here, and then this is the chat template, and then assistant will be given as the will be given a prefix, and then this is for the DPO task. So we're just taking the prompt from the user message, etc., etc., and we're defining a few edge cases where if the message is not found from the user, then um, use the whole chosen list as a prompt. And then this is so this is for getting the assistant messages. So basically when a user types a message, the assistant will be giving a reply. So this is for that part. And then yeah, so apply template to chosen or rejected responses. uh, Everything else is done here. So what text which you choosing, what is the text that we are rejecting. I commented this out because we already did the stripping part. And then yeah, everything, this is for the data preparation, I would say. So it is done and it is defined. So this is for the data set. So as I've already mentioned in the uh, GitHub, we're using the ultra feedback binarized dataset. This is for that. We're just taking the training and the testing split and then loading the dataset, sampling it, and then storing the columns, applying the formatting function, uh, formatting over here that is done, and also renaming the columns to what the DPO trainer expects by default. So there are some columns called text prompt, text chosen, text rejected. So that is what the DPO trainer will be expecting. So that is how we rename our columns to reflect to that. Yeah, all that is done. This is where the formatting runs. So as you can see, do you know something about crystallography and structure factor? So this is the chosen message that says it is a science of arrangement of atoms and solids and all of that. And then this is the rejected one. So this is the rejected message. So we have to, there are three different columns as you can see. So prompt is a question, and then what is a chosen prompt, what is a chosen reply, and what is a rejected reply. So these are the three different columns. So you can see all three of them here. And then this is nothing but we just configuring all of the variables and the parameters. So random state, dropout, bias, everything. And then this is where we're training the model. So we're giving all of the parameters, what is the training batch size, what is the warm-up ratio, logging steps. And this is the optimizer where we're using Adam 8-bit optimizer. What is the learning rate, etc. And setting, we're also setting the seed. All of that is done. So this is where the training process is happening, but I was facing some issue over here, but I was not able to fix that. So yeah, so this is for the DPO training, and then yeah, all that is done. And then this is the saving part, and then this is the loading part. So as you can see, this is a testing where I'm doing how can I learn programming efficiently. And then it gave me a few steps how can I learn programming. So choose a programming language, find a structured learning path, break down a learning process, and then practice coding. So it basically answered whatever you wanted. So this is all about the DPO. Let's go to ORPO. So basically they're very similar, I would say, like the way I was doing it. So this is for the ORPO, and the same model, but here I've saved it to a different output directory. Then loading of the model and the tokenizer. This is the data pre-processing. So basically the same thing, if it is the user prompt, if it is a system message, or if it is a assistant rejected message, or a assistant chosen message. So all of that is done here. Taking the same dataset, ultra feedback binarized. Then the same thing, training, testing, configuring of the LoRa, and then this is the configuring of the ORPO trainer. So yeah, this is all about the ORPO, and this is all about the DPO. Let me go back. So after that, let's go to the next part. So the next part is the custom checkpoint. So continued fine tuning from custom checkpoint. So what we're doing is we're loading a previously saved LoRa adapter checkpoints, and then from there we're continuing the fine tuning process, allowing for iterative improvement or adaptation. So basically here what we're doing is whatever LoRa checkpoint that we've saved, we're directly loading that, and from that we continue fine tuning process. So this will make it easier for us to like continue with the process, and instead of like doing from the starting again. Let me open the collab. Okay, so even for this we need the GPU, doing all of the installations. Sorry, yeah, doing all of the installations, and then getting all of the imports. And this is the base model. I'm using the Tiny Llama BNB 4-bit model, which is small, and we're using standard length. And then this is the LoRa configuration that we used. And then this is a phase one where I'm using so basically this is what I'll be saving my model to, and after that this is from where I will be continuing the fine tuning part. So this is output directory phase one, and this is output directory phase two. So first I'll be working on the phase one to uh, create a checkpoint after this phase 1, and then I'll be continuing from phase 2. So I'm just printing out all of the details what I'll be doing, and as you can see the data set, did I define it? I just have the data set and size and all of that here. So after that we have the model and then the tokenizer. So this is where I'm loading the model and the tokenizer. This is the phase 1 configuring of the LoRa checkpoint to the phase 1. So I'm doing that, and then I'm taking the Databricks Dolly data, that is the data set that I'm taking. This is the phase 1, so everything you can see is for the phase 1. So configuring trainer in the phase 1 and starting trainer. This you can see this is a training loss and the number of steps that we have. All of that is defined over here, and we're also defining the Adam W8-bit optimizer. So here I'm saving the phase 1 model. So this is where you can see that it'll be saved to this part. And then this is what I'll be doing. I'll be restarting, I'll be clearing all of the model and the trainer objects. And then this is from where I'll be uh, taking the checkpoint so that I can continue running with it. So I'm again loading the base model. I'm taking everything. So you can see that the base model is reloaded. And then after this is when I'll start with the continued pre-training. So this is for that. So LoRa configuration reapplied, and you can see all of the parameters that were defined previously, whatever is there. And then loading saved adapters from phase 1, everything is done, and then loading and preparing the data set again, the same data set. And then this is for the continued pre-training, I would say. So you can see that this model is the model with phase 1 adapters that is loaded from this particular cell previously. So this is the continued thing, and then this is the phase 2, which is nothing but the continued pre-training that we're doing everything, we're just saving. And yeah, this is how we do it. So you initially we trained a model, saved to one checkpoint, and then after that we restarted everything from the previously saved checkpoint. We continued with the pre-training. So this is a test part where we're doing. So yeah, this is all about using um, creating a custom checkpoint and then creating doing continued pre-training from that. So this, I think I'll finish here. I will do the next two parts in the next part. So yeah, that is nothing but the mental health chatbot and also the exporting to Olama. Thank you.